Alright, so here we are with the 5-6 assignment. Let's see how we do on that. So this was the law of sines, and so this first one here, solve the triangle. So we're definitely going to use the law of sines. Again, law of sines is apparent because the angle that you are given does not have a side measure across from it. And so we would use sine, law of sines, if we had that to set up a proportion, but we don't. And so in that case, we are going to use law of sines. Super. So that means that this is side B, this is C, and this is A, based on where the angles are. And so we are going to use the formula that uses angle B. So taking a look at our formulas, angle B is this one. So we're going to use that guy. So B squared is going to equal A squared plus C squared minus 2AC times cosine of B. Alright, so filling this in, let's see, we don't know what B squared is, we're trying to find that. 13 squared is going to be A, C squared is going to be 8, minus 2 times 13 times 8, times cosine of B, which is 131. Alright, so if we break this into pieces here, we can actually make B squared equal to the sum of, let's see, 13 squared is 169, 8 squared is 64, and then we have 2 times 13 times 8 times, make sure you're in degree mode, cosine of 131. Alright, so we're going to subtract 136.4603. Alright, so 169 plus 64 minus your answer. Oh, actually, that's plus because it was negative 1. Ooh, okay. So, we're going to do 169 plus 64 plus 136.4603. And then we're going to square root that. And so our B squared equals 369.4603. And so square rooting both of those makes a B of 19.22. Alright, so now that we know B, we can go ahead and find our angle measures using sine. So, law of sines. So, law of sines now says that sine of 131 over 19.22 could equal the sine of C over 8, or we could set up sine of 131 over 19.22 and have that equal to sine of A over 13. And so in both of these we will cross multiply the two numbers, divide by our side length, and so we end up solving the triangle of B as 19.22. Angle A, let's see, is going to be sine of 131 in degree mode times 13 divided by 19.22, but then the sine inverse of that decimal. So angle A is going to be 30.69, but that's going to be 70. And angle C can actually be found by just subtracting from 180. So I'll just do that because it's easier. So 180 minus 131 minus, what's the one we just got? 30.7. So angle C is going to be 18.3 degrees. And I did just pause the video and do it the algebraic way from down here, and that works as well. So it's all good. Alright. So those two are part of the answer as well. Alright, so this next one, we only have sides, And so we are going to have to work backwards here to get an angle. Doesn't matter which one we're going to do, so since we already wrote down the formula, let's go ahead and use this formula. Which means that we are going to have b squared. Oh, we already know what that is. This is b, this is a, and this is c. And so b squared is going to be 19 squared, and that's going to equal a squared, which is 27, plus c squared, which is 24, minus 2 times, oops, that's not a 2. I'm going to run out of room. So minus 2 times 27 times 24 times cosine of b, since we don't know what that is. Alright, so we have 19 squared, so that's 361, and that's going to equal our, kind of breaking this up into pieces, 27 squared, which is 729, plus 24 squared, which is 576, minus 2 times 27 times 24, so minus 1,296 times cosine of b. Alright, so what does that mean for solving? Let's subtract the 729 and the 576 over to the other side. So we're going to get 361 minus 729 minus 576. So we get negative 944 equal to negative 1296 times cosine of b. But of course we're going to divide by that divisor, or multiplier, so divide by negative 1296. This one's a lot of backwards work here. And so we get 0.7284 equal to cosine of b, and so we need to take the cosine inverse in order to do the opposite of that, which is funny because we're doing that in Algebra 2 right now. Or no, geometry. Woohoo! So that's going to be an angle B of 43.25 degrees. Alright, and so how do we find angle A, for instance? Well, now that we know what angle B is, we can set up sine of 43.25 over the B length, which is 19, and set that equal to sine of A, for instance. Apparently my pen just turned off. Okay, sine of A over the A value, which is 27. So we cross multiply the two digits and divide by 19. So sine of that 43 thing times 27 divided by 19, but then of course we have to take the sine inverse of that decimal. So that means that angle A ends up being 76.82 degrees. And then for angle C, we would just take 180 minus the A angle minus the B angle. And so 180 minus 76.82 minus 43.25 gets us a 59.93. Apparently I should give myself just a tiny bit more room to write on these. Alright. So, next one I want you to solve the triangle, but now there's not an image. Hey, that's okay. So, we're still going to need to find angle B. We still need to find angle C, and then we're missing side A. So, trigonometrically, again, we can't use the law of sines yet because we do not have an opposite side and its angle. So, that means that we are going to have to set up a law of cosines. Since we have angle of 55, that means that we're going to have to do the law of cosines that uses A. So we have to go with this one here. But they're all a pattern, that's the same. So we're going to have A squared equals B squared plus C squared, which sounds like Pythagorean theorem, but hey, then we're going to subtract 2 times BC times the cosine of A, the angle. Alright, so filling that in, let's see. We don't know what a squared is, so we're trying to find that. But b is 12, and c is 7. And then cosine of a, which is 55. So we're going to break this into its 3 values to equal a squared. So 12 squared is 144, 7 squared is 49, and then we have 2 times 12 times 7 times cosine in degree mode of 55. So we have 578.1650. Alright, so 144 plus 49 minus 578.1650. Leaves us with an a squared of a negative number. So let's see what happened there. What are we doing? Oh, watch. Okay. Are you thirsty? Are you thirsty? Are you? Okay. Good water? I love you. I love you.
Am I going to go to school on this day?
Yep. And Logan's going to school this day. I know. That's not happening for a week. And apparently you got to have some interactions. Okay. So, moving on. We're just going to keep recording. Okay, we're given all side lengths, which means that we are going to go ahead and find, sure, A, since it's, actually, we're going to see if this triangle exists. Ha! So, what are the 2 smallest sides? These ones. And do they add, in fact, to be greater than the 3rd side? They don't. And so, because of that, we cannot form a triangle. Darn. Alright, so let's try the next one. And again, we're always checking if there are 3 sides that the triangle would exist. And of course this one was an image in number 3, so that's a little easier to check. But this one here, let's see, the 2 shorter sides should be adding to be larger than the 3rd side. So 3.2 and 6.4 is 9.6, and that is bigger than 7.6. So we're good. It'll make a triangle. Just like in Law of Cosines, we want to make sure that the adjacent side might be longer than the opposite side, and then we would end up having 2 triangles to solve. So just one of those steps to do at the beginning. Kind of like factoring and always finding a greatest common factor first. So, I'm going to do A, so I'm going to find angle A by doing a squared equals b squared plus c squared. And then that's going to subtract 2 times b times c times cosine of, A, there. So a squared is 3.2, squared. B is 7.6 squared, and c is 6.4 squared. B is 7.6, C is 6.4, and then times cosine of A. Alright, so let's find each of these values. Let's see, 3.2 squared is 10.24. 7.6 squared is 57.76. 6.4 squared is 40.96, and then we have 2 times 7.6 times 6.4. So minus 97.28 times cosine of A. Alright, so what does that mean algebraically? We're going to subtract that 57 number and that 40 number to the other side. So 10.24 minus 57.76 minus 40.96. So we get negative 88.48, but that's going to equal negative 97.28 times cosine of A. So how do we solve that? We divide by our multiplier. And divide by negative 97.28 means that we have 0.9095 equal to cosine of A, or of course I need to take the cosine inverse, because then the cosines will cancel and we'll have angle A equal to cosine inverse of that is 24.56 degrees. Alright, so that's our first angle, but now that we have angle A, we can go ahead and use sine, law of sines, so sine of 24.56 over A, which is 3.2, can get us our B value, so sine of B over 7.6. Again, cross multiply, divide by our last digit, and then take your inverse. So sine of 24.56. Actually, I have the decimal still in my calculator, so sine of the decimal times 7.6 divided by 3.2 equals 0.987, but sine inverse of that, so angle B is 80.78. Alright, so then how do we find angle C? Angle C is going to equal 180 minus angle A minus angle B. So 180 minus 24.56 minus 50.78. Is that 50 or 80? Oh, that's an 80. 80.78. Looked like a 5 to me. Okay. So 74.66. Perfect. For angle C. Alright. Could we do some more of these? Okay, that sounds great. Here we go. Alright. So let's see. In number 13. Just to double check, because we are actually given an A and an A, that means that law of sines might be here, meaning there might be that alternate version. So if we look at our triangle with 42 degrees over here for A, opposite side of 7, adjacent side of 10, it turns out that we might have our two triangles. The answer key does not have that. That's interesting. Okay. So on that note, we're going to try them. So we're going to do sine of 42 over 7, and we're going to set that equal to sine of B, we don't know, but over 10. So let's see, I'm going to multiply across here and divide, and then take the sine inverse. So sine of 42 times 10 divided by 7, but then the sine inverse of that. So that means that angle B is actually going to be 72.9210, which means that the alternate to angle B is going to be 180 to get the new B value of 180 minus that answer, 107.0790. So we have two problems now that we can use. So in this next one here, we don't have a side C, so we are going to have to use law of cosines. So law of cosines with, oh, we can find sine C, never mind. Angle C is going to be 180 minus our angle A, which was 42, minus angle B. So angle C is going to be minus 42 minus 72.9210. Alright, so angle C is 65.079. Angle B was 72. And so we need side C, which means that we're going to do sine of 42 over 7. I always forget that you can subtract from 180 to get the missing angle. I always want to do like some complicated thing. Alright, 079 over C, because we don't know what that is yet. So we'll cross multiply, boop, and divide, meaning sine of 65-ish times 7 divided by sine of 42 gives us a C value of 9.49. Alright, but then the other side, we're going to get angle C by subtracting from 180, so 180 minus 42 minus 107.0790. Sweet, so angle C is going to equal minus 42 minus 107.0790. Alright, so angle C is going to be 30.921 degrees, yay. And so then we have that, and angle B, and now we need to set up our proportion. So our initial setup was sine of 42 over 7, but now we get to set that equal to sine of 30.921 over C. So we don't know the alternate C value. So then we cross multiply and divide by sine of 42. So sine of 30.921 times 7 divided by sine of 42, boop, is a C value of 5.37. Oh, 38 if we round appropriately. Alright. So, yikes. Okay. Alright, so the next one says that it's not possible in the answer key, so we're going to just start like we didn't know that and see it's probably because B is 11.1, so we'll see. So, starting this one out here, we've got some space, sine of 63 over 8.6, and we're going to set that equal to sine of, we don't know, for B, over 11.1. And so we'll cross multiply, whoops, not that way, this way. And so we get sine of 63 times 11.1 divided by 8.6. That's why, because I'm going to do sine inverse of a number that doesn't exist. So that's not possible, because we're trying to do sine inverse of, let's see if I can get it back, times 11.1. We're doing a sine inverse of 1.1500, and that's going to be an error. Boo. So, no triangle possible. Basically, you can only ever take an inverse of a tangent when it's greater than 1. Otherwise, everything else will become an error. So, whoops. Alright, so then we're going to do some areas of triangles. So that's the next one here. Find the area of the triangle. And remember that we get to use both of our formulas depending on what's given. So this one here, we have an angle given, right? And then this one here is only sides. So, taking a look at what we have, we do have an angle, and so we're probably going to end up using this idea of half of the two sides that don't have the angle times sine of the angle. So, half of the two sides that don't have an angle times sine of the angle. Let's double check I wrote that down right. Okay. So, plugging that in, we've got a half times 32 times 19 times sine of 47. Alright. Woohoo! And so we get an area of 222.33 feet squared, because we're talking about area. Alright, next one is the same idea, only now we're going to be doing a half of A and C times sine of 101, which is B. And so we get a half times 10 times 22 times sine of B. So, sine of 101. So we have an area for this one of 107.98 centimeters squared. So just knowing we have that formula. Alright, then the next ones, we're going to decide whether a triangle can be formed, and then we're going to use Huron's formula. So that's this guy right here, because it's all about sides. So taking a look at all of these, the shorter two sides, again, need to add to be bigger than the other side. So is 9 bigger than 8? Why, yes it is, so we can solve that one. Here we have 8 bigger than 8. Oh, sorry, so no triangle. Alright. Then the next one, we need to know if 19.3 plus 22.5 is bigger than 31, which it definitely is. And we need to know if 22.3 and 28.5 is bigger than 33. Yeah, that definitely is. So that means that we get to use the semi-perimeter formula. So remember that we're going to find S first, which is all of the side lengths added divided by 2. So looking back on the first one, S is going to be 4 plus 5 plus 8 divided by 2. And so we have 8.5. And then the formula for the area says that you're going to take the square root of the S value, but then all of the subtractions with every side. So 8.5 minus 4, 8.5 minus 5, and 8.5 minus 8. Alright, and this will be the last one that we'll do on this video because we're running out of time, but that means I have the square root of 8.5 times 8.5 minus 4, and 8.5 minus 5, and 8.5 minus 8. Alright, so we have square root of 66.9375, meaning boop, 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 8.1815. Doesn't say anything about units, so we'll just write the word units squared for area, and there's our solution. Alright, so we will do number 25, 27, and then the last few on our next video.